Show you 500 Seinfeld episodes. And you say George or Kramer?
Hello, and welcome to Movie Phone. If you know the name of the movie you'd like to see, press 1. Come on. Using your touch-tone keypad, please enter the first 3 letters of the movie title now. You've selected Agent Zero. If that's correct, press 1. What? You've selected Brown-Eyed Girl. If this is correct, press 1. Why don't you just tell me the name of the movie you selected? Shuttle? To find the theater nearest you, please enter your 5-digit zip code now. Why don't you just tell me where you want to see the movie?
Lowe's Paragon, 84th and Broadway?
Shut is playing at the Paragon 84th Street Cinema in the main theater at 9:30 p.m.
Yeah, now I catch it.
It's also playing in theater number 2 at 9 o'clock.
So I'm showing you this because it's like one of my favorite voice user interfaces or conversational user interfaces. It's Kramer here trying to pretend to be what we call an IVR, interactive voice response system. And the line, why don't you just tell me where you want to see the movie? That's what makes it so funny. And even today, you're still laughing about it because you still think it's so unbelievable that a system could respond to you in this way. So I have a couple of slides that I would like to show you just to motivate you a little bit for conversational user interfaces, and then we go a little bit deeper on the Alexa side. So to get started, I would like to just run you through a couple events in the history. So very quickly, we go back to 1977, which is an important year since the Apple II got introduced here. 4 years later, the IBM PC got introduced. And then in 1984, we have the Macintosh.
Hello, I am Macintosh. It sure is great to get out of that bed.
So the first time a computer really talked to us, right? It also was the beginning for computers being used for media production and media consumption. In 1995, it took 11 years really to get the graphical user interface fully established. And I'm trying to make this a point because if we are now talking about voice user interfaces or conversational user interfaces, this also is not going to happen overnight. It took the GUI 11 years. So now we jump all the way to 2007, which is an important year because the iPhone got introduced. It's also important because at the same time, the same event even, OS X Leopard got announced, and this OS had a voice synthesizer that is much better than what we heard just with the Mac. Come on. Sorry,
OS X includes an advanced speech synthesizer that provides high-quality synthesized speech.
So a lot better than what we got in 1984, and also this was available now as an API. So application programmers could include it into their own applications, could make them speak. 2011 is important because of Siri, of course, right? Siri got introduced.
See, it doesn't make sense, and Cookie Monster is said that there are no cookies, and you are said that you have no friends.
Sassy. And then it happens really very quickly now. 2 years later, Google introduced us to Google Now, their assistant.
Forecast for Ramona is 86 degrees and clear with periodic clouds.
Different voice. A year later, Microsoft comes with Cortana.
I know you know this, but I'm saying it anyway. I'm in a phone.
From all of the assistants, the best voice experience, I think. So natural. And then a year later, the Alexa gets introduced. I'm surprised she's not coming on. Alexa? Hello?
Hi there.
Alexa, tell me a joke.
A jumper cleaner walks into a bar and asks for a beer. The bartender says, okay, but don't start anything.
So then this year is probably the year of the chatbot. At least it's currently very much overhyped, and it's a whole new experience that borrows some of the concepts that we see in voice user interfaces. So from the standalone text-based user experience 39 years ago, we went all the way to now have a globally connected conversational voice user interface. So how would we actually build an application that we could talk to? What components would we need to build that? We need a speech input device like a microphone. Then we need something that can like compress it, send it to a speech recognizer. The speech recognizer would now transcribe it for us, would send us back text, and then we would try to map that text into reprogrammed actions and execute them for our users. So I tried that, and I think I've even showed you that application maybe a year ago or 2 years ago. It's a little doodle app. It's an Android app, and you just use it. The screen is your canvas, and your finger is your paintbrush. You just draw, you doodle on that thing, and if you tap on that menu icon, the whole screen gets overlaid, and you get lots of buttons to choose. So you can choose your tool, that is like your pencil, your brush, or your roll, and you can also choose your style. That could be you draw embossed, or you blur, or you blend. Blend is actually very cool. When you blend colors, it picks up the color that is underneath and merges it with the color of your pencil. And then you get different tools to select your color. The difficulty here, however, is that it takes you 7 or 8 touches until you have your tool configured in the way you like it. And I thought voice could help you with that. You could just say what you want. So I added a microphone to it, and I went through exactly the steps I just told you. I looked at what kind of commands could a user speak. You could say explore, publish, or share, or print. You can select as tools, of course, like pen, brush, roll, the styles, and then I have 216 name colors in that system. And here you can just see the blue shades. So now you start then building a grammar. And there's a standard for that called GRXML, this W3C standard. And this is how IVRs are built. So you build a grammar and you define rules. And so you say, well, I have 3 tools, and I have 216 colors, I have 5 styles. And then I can say a color in a tool, in recursive order, of course. I can say a tool and a color, I can say a style in a tool and a style, and so on. To make it really difficult, you can say all 3 things. You can say color, style, tool. And again, you can say that in all the different permutations. And so you build all these rules, it creates an XML document, and you load that into your speech recognizer.
Ain't no love in the heart of the city. Ain't no love in the heart of the city.
That's Bobby Blue Blend.
Ain't no love.
Blue superstar who died just 3 years ago in Memphis.
Ain't no love when you
So good old Bobby is responsible for, if I say Blue Blend into the speech recognizer, it comes back with Blue Blend spelled as an A. But there's more. If I say powder blue brush, very often it comes back with powder blue I say turquoise blur brush. It comes back with turquoise blur price. Must be a very popular flip-flop. I say cyan brush. It comes back with Diane brush. Or I say sky blue embossed pen. It comes back with sky blue in Boston, which is a famous female soccer club in Boston, Massachusetts. And this is how the speech recognizers work. They work off statistical models. So words that are being said often and words that are being said often together get a higher priority, and so that's why you see all these false responses that I get from the speech recognizer. And this is from one of the best, it's from Google Speech Recognizer. And there are more problems. There are homophones. Those are words that are pronounced exactly the same but have a different meaning. Synophones, words that are pronounced similarly but have a different meaning altogether. So with all these difficulties, it was very hard to build a system that I could use in my Android application to make the life of my little doodlers a little bit better. So along comes a system now that approaches this problem completely differently. We now look at this whole speech recognition and natural language understanding problem just as a black box. We put in whatever the user says, and we get a JSON document back describing the user's intent. We feed into that black box an intent declaration with entities, and I will tell you a little bit more what that is. We also feed into it sample utterances. And that goes a little bit more what you just heard. The sample utterance, think about them, are just the sparrows. And we also may provide custom dictionaries. And what's remarkable about this is how much simpler these applications get now if you build them on this system. So before we were building IVRs and we were totally focused on the user's expression. So we were trying to build into rules exactly the words that a user was saying. With that new approach, the focus shifted on the user's objective. We now focus, what does the user really want? A couple of companies have picked up on that. The first one I learned about was WithAI, a company that was quickly acquired by Facebook. But the approach that all these companies that I will now talk about take was very much the same. So you start by declaring an intent. So an intent, for instance, could be, I want to set up my tool, my little doodle tool. And that intent can have entities. Some companies call it slots. Think of entities as you would think of a parameter. So, and for me that of course would be like maybe the color and the style and the tool I would like to use, right? Those are entities into my intent to set up my tool. And then I teach it by giving it sample utterances. And so you heard me say blue, blur, brush. That would be one of the stupid utterances that nobody says in his right mind, but the recognizer will understand it if you teach it. So here's what the system comes back with after a while. Give you a JSON document back that has clearly identified the style I would like to use, blur, the color, blue, and the tool, the brush. So just by now parsing that JSON document, I can easily consume that in my Doodle application and select the tool exactly like the user wants it. Another company that just yesterday was acquired by Google, API AI. The very same approach. You teach it by providing sample utterances, you declare the intents, and you declare the entities. The result pretty much the same. I get a JSON document back. The schema is a little different, but the result for me is the same. I can parse a JSON document any day. And finally, the Alexa Skills Kit again works in exactly the same way. We built an intent declaration in JSON. They call it not entities, they call it slots. They have a couple of slot types predefined, and you can define your own custom slots, providing custom dictionaries. So for us, a financial company, we want to like build an intent, for instance, what's my balance? What do you think? What kind of entities or slots would I need? The count type would be one. Like I would like to know the balance of my checking account. So checking, savings, credit, those were viable entries for an entity type. Or a dictionary with all the different bank names. What's the balance of my Bank of America checking account, for instance? A little bit a different approach is taken by chatbots that compete for the Loebner Prize. Because the Loebner Prize happens, I think, since the year 2000 about, where AI systems try to compete, performing the Turing test, and it works like this, where a judge has a conversation with two different chat windows. One, he talks with the human, and one he talks with an AI system, but he has no idea which one is which. He has 25 minutes, ask questions, and then he has to make up his decision, and has to make up his mind. And I don't know if you can read this, it's pretty small, I'm sorry, but this is the conversation that one of the judges had, and the Loebner Prize just happened last weekend. And in all these years, in all the like 16, 17 years that the competition now happens, not once has a Turing test been won or completed. So every year, the judges can clearly identify the human from the AI system. But they still give out a kind of a bronze medal for the best AI system that they find. Interestingly, almost all the contestants work with the artificial intelligence markup language. It's an XML dialect, and I have just one small example of how that works. So you define a pattern, and this is what you expect the user to say. And the little asterisk here would be like the variable. So I define a pattern where I say, what is star? And if I come across that pattern, then my answer would be, I don't know what star is. So I think you already get the idea. If I say, what is cheese? The system comes back as, I don't know what cheese is. And you can get a little more sophisticated, putting the person tag around the star tag. And then you could have a conversation like this. I like coffee. The AI system returns, I see you like coffee. And I say, I like your voice. The AI system comes back and says, I see you like my voice. It gets lots and lots more complicated if you look through the AML specification. You can really build a bot that works very well and can fool at least some of the judges. So we built one of these. Actually, this is the bot that won yesterday, the bronze medal. We built it into Slack to just. I want to see if we can just show you how this works. Well, wait on it, show you after the break. You can see this one. So I wrote a blog post where you can easily follow how you can set up any kind of bot into Slack, for instance. It's a simple webhook. So maybe to summarize where these voice and chatbot user interfaces belong in a bigger theme, you see that we currently kind of move away from the desktop a little bit. We have in 3D virtual reality environment, we have the 2D desktop, and 2D, think about it, if you move your mouse on your mouse pad, that is just 2D. We have a texting environment where we talk to chatbots, and that is what I call a 1D experience. It's very limited in by providing you really strict rules to follow a timely hierarchy. It's hard for you to go back in time talking to a chatbot. And then we have almost a 0D experience where we have a system like Alexa where it's really hard to keep context. So think about if you wanted to navigate inside of a list of 10 items using just your voice. Like imagine I asked Alexa, what were the last 10 transactions on my checking account? And then it would start telling me those, and I said, oh, go back 3. For me, it would be very hard to build a mental model around that, to know exactly where I am with that list. So all these different environments, of course, have their advantages. So I think we currently see that for the text bot or chat experience, we see that the consumers are mostly on Facebook Messenger, at least in the US. In China it's WeChat, in Europe it's WhatsApp, but here in the US most of the chatting happens in Facebook Messenger. On the business side, much more of that happens in Slack. And I put API AI underneath that because you could build your natural language understanding system in API AI and feed into both. And then on the voice side, I think we currently have Alexa as the only game in town here. There's nothing that comes close to it. And I think it's mostly because of their advantage that they have with the hardware. So that is the little Alexa here. The bigger one has a much better speaker. The microphone array is pretty much the same in both devices. So the microphone array allows you to speak to it, even if there's surrounding noise, if there's music that's been played around, it still can identify very clearly where you are standing, from what position, or what location you are talking to it. And that makes it really good when it comes to the speech recognition results. So still, I think when we look at this, what's happening outside of our typical desktop or mobile experiences, voice on one side and text on the other side. And if you look at it with the voice approach, it's much more a passive approach. I can just walk into a room and say, hey Alexa, and then it asks for a service. What's the weather like? Doing the same as a chatbot, I still have to pull out my phone, have to open the chat application, have to identify myself, have to start texting, maybe have to identify the chatbot first that I want to talk to. So it's much more an active approach. Still, that chatbot experience can still almost feel like talking to a real person. And I think this is what makes both the voice computing side and the chatbot makes it currently so different from application that we are used to. Right? The personal touch can now really be here. So we don't know yet. Will there be a winner? Will they be both living side by side for a long time? I think the chatbot experience seems to be more like a transition to me. Transitioning to a voice experience. And unlike mobile and social that work really hand in hand, I think the chatbot and the voice experience do not share the same. So you guys want to take a short break, and then we go into the Alexa skill kit?
Yeah, we can take a break. That's good. Still a lot of pizza. You want to eat any?